Welcome back, everybody, for another deep dive. And this time, we're going to be looking at a question that has fascinated people probably forever. Can we see the future?
It certainly has been one that's been around for a while. But the really cool thing is, with all the stuff you sent over about all this new science, it seems like we're getting some possibilities that are a little less like, Nostradamus and a little more like hard science.
Right. And we've got a lot of sources here. I mean,
Yeah.
this is a big one. This is a big topic. We've got quantum physics articles. We've got stuff about black holes. And we even have some really interesting studies about the human brain.
Yeah, and that's the part that always gets me, the idea that we're not just talking about vague predictions, but we're talking about, quantum mechanics and time travel theories, and maybe our brains themselves can kind of, step outside of time.
Okay, well, let's jump right into it. And I think the best place to start is somewhere that is both terrifying and exhilarating, and that is black holes. One of our sources, The Future of the Universe Through a Black Hole, suggests that falling into a specific type of black hole could theoretically allow you to witness the entire future of the universe. Wow. I mean, that's a pretty wild idea.
It is wild, but it's not totally, out there. I mean, the concept is actually based on something called the Kerr metric. You've probably heard of that.
I can't say that I have.
Well, it describes the space-time geometry around a rotating black hole.
Okay.
And it also applies to charged black holes.
Okay.
And what it suggests, basically, is that within these particular types of black holes, space-time is warped in such a way that you, as an observer, could potentially see the entire timeline of the universe unfold.
So instead of just, getting crushed into oblivion, like we always think about with black holes,
Yeah.
you might actually see the entire history of the universe.
Right. It's not just, things going in and being destroyed. The nature of space-time in these black holes is totally different. It's like a different kind of journey through time.
So it really does kind of challenge that classic image of a black hole as like a cosmic vacuum cleaner.
Yeah, exactly.
Okay, well, let's shift gears a little bit and talk about a different way to think about time.
Okay.
We've got this source here, Navigating Through Time, and it talks about how time speed is actually connected to the expansion of the universe. So,
Yeah.
so is there any science behind that? Is that just kind of a fun idea?
Well, it's definitely a specific way of looking at it, but it is connected to some pretty important physics concepts.
Okay.
Basically, the idea is that as the universe expands, time itself stretches and slows down. So it's kind of like the universe is a giant clock, and as it gets bigger, the ticking gets slower.
Okay.
The idea is rooted in how we measure time. Like, we measure time through events, right? Like atomic vibrations.
Right.
But those vibrations are affected by, the fabric of space-time itself. So as the universe expands and stretches, those vibrations could theoretically slow down and make time seem to pass more slowly for us.
Okay, so that's a pretty mind-boggling concept right there.
It is.
And this source also mentioned something about solar flares and how they could be related to this expansion, which is not something that most people would think about.
Yeah, because the universe is expanding at a particular speed per unit distance, you can actually view that as a frequency. So this source is suggesting that the expansion might be easier to detect during events that create intense light waves, like solar flares.
Okay.
And this is where it gets even more interesting, because there's this observation that the decay rate of radiation from something called manganese-54 actually changes 36 hours before a solar flare.
Wait, so are you saying that if we observe changes in this manganese-54, we could predict solar flares almost 2 days in advance?
It's tempting to think that way, right?
Yeah.
But it's important to remember correlation versus causation. Just because two things happen close together doesn't mean one causes the other.
Okay, fair enough.
But it does raise this question, could detecting subtle shifts in space-time, like from the expansion or maybe other cosmic events, give us like a window into the future? Just a little peek.
Okay. I mean, that's a pretty tantalizing thought right there. Makes you wonder what else is out there that we might be missing.
Yeah.
You mentioned detecting these shifts in space-time, and I'm thinking about gravitational waves now. Is that kind of where we're going?
Yeah, it is. And, those ripples in space-time caused by massive objects moving around.
Right.
Well, there's this place called Nanograv, the North American Nanohertz Observatory for Gravitational Waves. And they use these waves to study the universe, and they use pulsars as their tool.
So those are those incredibly dense, rapidly spinning stars.
Right. They're like cosmic clocks that help track these gravitational waves.
So it's like using the whole universe as a giant scientific instrument.
Exactly.
Pretty amazing. And I remember reading that Nanograv has made some groundbreaking discoveries using this technique, right?
They have, and this is where things get really interesting because one source suggests that since the universe is constantly expanding, the space between these gravitational waves is also expanding, and those expanding gaps could actually create measurable differences that are like markers for future points in time.
Whoa, so you're saying that these expanding gaps in the gravitational wave patterns
Yeah.
are like timestamps from the future, like little messages saying, hey, this is going to happen.
That's one way to think about it, yeah. And detecting those subtle shifts in the patterns could theoretically offer insights into future possibilities.
So it's like we're reading ripples from events that haven't even happened yet.
It's a wild idea, but remember a few years ago when LIGO, the Laser Interferometer Gravitational Wave Observatory, detected those gravitational waves for the first time.
Right.
I mean, what was once purely theoretical is now something we can actually observe.
Yeah.
So the idea of reading future echoes in these gravitational waves, it's not so crazy anymore.
That's amazing.
Yeah.
But if these signals are so subtle, how could we ever hope to actually decode them and understand what they're telling us about the future?
Well, that's where we need to go even deeper down the rabbit hole and into the world of quantum mechanics and a concept called retrocausality.
Okay, are you ready for a quantum adventure?
I think so. Let's go.
Lead the way.
Okay, imagine a ripple in a pool. It starts at a point and expands outward, right? Well, retrocausality suggests that ripple could go outward and then suddenly converge back to its origin like it's going back in time.
Okay, that's a tough one to wrap my head around.
It's like saying cause and effect can be reversed, the future can influence the past.
Okay, so is there any actual science to back this up, or is this just like a thought experiment?
Well, there are some pretty interesting studies out there. One source mentions an experiment where researchers used quantum entanglement to simulate something called a closed time-like curve.
Okay, before we go any further, can you explain what a closed time-like curve is? Because that sounds like something out of Star Trek.
Think of it like a path through space-time that loops back on itself. So you're essentially traveling in a circle through time.
Okay.
And these researchers, they were able to manipulate entangled particles to create a situation where information seemed to be traveling backwards in time within this simulated closed time-like curve.
So they're using entanglement, that spooky action at a distance, to simulate time travel effects.
Yeah, pretty wild, right?
That's incredible.
And this is where things get even crazier, because it leads to the idea of quantum computers. Some scientists believe that by using retrocausality, we could create quantum computers that could process information from the future to solve problems in the present.
Wait, are you saying future quantum computers could use information that doesn't even exist yet to help us with problems today?
That's the idea, and it really shows how the line between science fiction and reality is getting blurrier, especially in quantum physics. What was impossible is now being tested in labs all over the world.
Well, we've journeyed from black holes to quantum mechanics and all this mind-bending physics. And I have to ask, is there anything about seeing the future that doesn't involve some crazy concept?
Well, there's one piece of the puzzle we haven't talked about yet, our own brains.
Our brains.
What if the most incredible time-traveling future-seeing machine is something we carry around with us all the time?
You're talking about our squishy gray matter brains being able to tap into the future.
Exactly. And there's this growing field called quantum biology that looks at how quantum phenomena might be happening inside living things. And there's this study called quantum computation in brain microtubules that suggests these tiny structures inside our brain cells might be capable of quantum computation, even retrocausality.
Okay, so you're saying that my gut feeling to leave for work 5 minutes earlier this morning because I thought I might miss the bus was actually a message from my future self.
It's an interesting thought.
I mean, it's an interesting thought, but I have to admit, I'm a little skeptical about all that.
I understand skepticism is healthy, especially with these kinds of ideas. But quantum biology is a really young field, and we're just starting to figure out how our brains and consciousness really work. And there's this other fascinating idea from a bigthink.com article. It suggests that consciousness itself might rely on quantum entanglement.
Oh, yes.
So imagine our awareness of the world could actually be tied to particles that aren't even limited by linear time.
So are you saying that our brains are like these organic quantum computers constantly sending and receiving information from different points in time?
It's a bold idea, and it definitely needs more research. But think about it. Our brains can do incredible things. We can remember things from the past, imagine future scenarios, and even experience time slowing down or speeding up in intense moments.
Right.
Maybe these are just hints that we're connected to time in ways we don't fully understand yet.
This is a lot to take in. But the idea that our own minds could hold the key to understanding time and maybe even seeing the future is pretty exciting. So
Yeah.
where do we go from here?
Well, there's one last piece to this puzzle, and that's quantum entanglement. And remember, we talked about it with those time travel experiments. Well, entanglement isn't just about things being connected over distance. Some scientists think it could also work through time.
So entangled particles could be linked across time, not just space.
Yeah.
How does that even work?
Okay, imagine you have two coins, and they're flipped at the same time they're entangled. So if one lands on heads, the other has to land on tails. Now imagine one coin is flipped today, and the other coin exists in the past because they're entangled. Flipping the coin today instantly determines what the coin in the past landed on, no matter how much time has passed.
Whoa. So you're saying that by messing with entangled particles in the present, we could actually change things that have already happened?
It's a wild implication, and it really changes our whole conversation about seeing the future, doesn't it? And there's this source, quantum entanglement could stretch across time, that explores this idea of influencing the past through things we do in the present.
I think we need to take a minute to really think about what all of this means.
Yeah, definitely. Yeah, it really makes you think about time in a whole new way, not as a straight line, but more like a web where past, present, and future are all connected.
Yeah, that is fascinating. But it also makes me think about paradoxes. If our actions in the present can ripple back in time, wouldn't that mess things up? Like, what about that classic grandfather paradox where you go back and accidentally kill your own grandfather?
Yes, the grandfather paradox, a classic time travel dilemma. But some physicists believe that retrocausality wouldn't necessarily lead to those kinds of paradoxes. They think the universe might have a way of keeping things consistent, like a self-consistency mechanism. So any actions we take in the present could only affect the past in ways that still lead to our current reality.
So no accidentally erasing yourself from existence or creating weird alternate timelines?
Probably not.
Okay, that's a relief. But if we're talking about influencing the past, does that mean free will is just an illusion? Or are we all just puppets on strings playing out some predetermined script written in the fabric of the universe?
That's a really deep question, one that philosophers have been wrestling with for ages, and quantum mechanics definitely adds another layer of complexity to it. It challenges our traditional ideas of cause and effect and suggests that maybe randomness and probability are much more important than we thought.
Right.
But whether that completely eliminates free will is still up for debate. There's no easy answer.
It feels like we've covered so much ground in this deep dive we've explored, seeing the future through black holes, the idea that time's speed is tied to the universe, expanding that mind-blowing concept of retrocausality, and even the possibility that our own brains could be like quantum time machines. So after all of this, can we actually see the future?
Well, it's important to remember that a lot of what we talked about is still theoretical. This is all cutting-edge science, and we're just starting to understand these really complex ideas. But what's exciting is that things that used to be pure science fiction are now becoming serious scientific research.
Right.
Our understanding of the universe and time is constantly changing and evolving.
So while we might not have those crystal balls or time-traveling DeLoreans quite yet, maybe the possibility of getting glimpses of the future or even influencing it isn't so crazy after all.
Exactly. Think about how far we've come in science. We used to think the Earth was flat, and now we understand the vastness of the cosmos. We figured out atoms mapped the human genome and created artificial intelligence. Humanity has a knack for pushing the boundaries of what's possible. Who knows what breakthroughs are waiting for us, especially as we keep digging into quantum mechanics and the nature of time.
It really is an exciting time to be alive, especially if you're fascinated by the universe like we are. But beyond just satisfying our curiosity, are there any practical uses for these mind-blowing ideas we've been discussing?
That's a great question, and scientists are definitely looking into that. For example, the idea of using retrocausality in quantum computing could completely revolutionize how we process information. We could have super powerful computers that could solve problems that are impossible for our current computers to even handle. Imagine using those computers to model complex systems like climate change, or design life-saving drugs, or even simulate the entire evolution of the universe.
That would be incredible. So while we might not be able to predict lottery numbers anytime soon, these discoveries could have a huge impact on how we understand the world and how we tackle some of the biggest challenges facing humanity.
Absolutely. And beyond the practical applications, there are also some really profound philosophical implications to consider. If we really can influence the past or get glimpses of the future, what does that mean for our place in the universe? How does it change our understanding of free will, responsibility, and even the meaning of life itself?
Those are some really big questions. It's like we're on the edge of a whole new way of understanding reality, where time isn't a rigid line, but more like a fluid, interconnected tapestry.
I like that, a tapestry woven with threads of entanglement stretching across both space and time. And as we keep exploring those threads, who knows what amazing patterns and connections we'll find.
We've covered so much today, from the mind-bending physics of black holes and quantum mechanics to the big philosophical questions they raise. But before we wrap up this deep dive, there's one more important thing we need to talk about: the ethical implications of seeing or influencing the future.
That's a crucial point. Imagine a world where we could predict natural disasters, prevent accidents, or even know the results of elections before they happen. The impact on society and people's lives would be enormous.
And what about the potential for misuse? Could this knowledge be used for personal gain manipulation or even to control other people? It's like opening Pandora's box. Once we have this ability, there's no going back.
Yeah, it's exciting and a little scary to think about a world where we have that much knowledge about the future.
Yeah, it really is. And it shows just how important it is to think about the ethics of all this research as we learn more. We need to be prepared for the consequences, both good and bad, and make sure these incredible discoveries are used for good and not for harm. That's a big responsibility. But it's a conversation we absolutely need to have. If science is taking us in this direction, then we need to be ready for some pretty big changes.
I completely agree. We're basically sailing into uncharted waters here, and our moral compass is going to be just as crucial as all the fancy scientific tools we're developing.
Well, we've taken our listeners on quite the journey today, from black holes to the inner workings of our own brains, all to try and answer the question, can we see the future? And while we may not have a definitive answer yet,
I think we've learned that the future is way more interesting and complicated than we ever thought. And maybe the idea of getting glimpses of it or even influencing it isn't as impossible as it used to seem.
we've explored some mind-bending physics and thought about some really deep philosophical questions. But I think the biggest thing our listeners should take away from this is that sense of wonder and possibility.
Definitely, the universe is full of mysteries. And as we keep exploring them, we're bound to find even more mind-blowing things. The quest for knowledge is a journey through time. It connects us to the past, illuminates the present, and shapes the future.
Couldn't have said it better myself. We've given our listeners a lot to ponder today, from the vastness of black holes and the expanding universe to the strange world of quantum entanglement and the potential of our own minds. We've really explored the edges of what we know about time and our place within it. And even though the question of whether we can see the future is still open,
I have a feeling that the search for that answer is going to lead to even more incredible discoveries and insights.
it's a journey that never really ends, and we're just taking the first few steps. Thanks for joining us on this deep dive into the mysteries of time and the future. Until next time, keep looking up, keep asking questions, and keep exploring the wonders of the universe.